All right, so to differentiate e to a power, we have a special rule, and that rule is that we rewrite the exponential. So we rewrite the e to the u, and then we multiply by the derivative of the exponent. And we talked about in class that this derivative of the exponent is really because of the chain rule, because e to a power is actually an inner function where the inner function is u and the outer function is e to the u. So if you look at taking the derivative of e to the 3x plus 4, what you'll do is you'll first notice, because it's e to a power, that you need to rewrite the exponential. So you'll have e to the 3x over 4. And then you need to take the derivative of the exponent. Now, before we take the derivative of the exponent, I just want to go off to the side here and talk a little bit about this. So like if you have the derivative of 3x, you would just say, because of the fact that it's x to the first, that the coefficient would be equal to your derivative. Now, here we have the derivative of 3x over 4. But it's the same principle as just the derivative of 3x. We have x to the first, and so our derivative will be the coefficient, and in this case, the coefficient is 3 over 4. So going back over here, when we need to take the derivative of this exponent as step 2 of our rule, again, because it's x to the first, our derivative will just be the coefficient, which is 3 over 4. Now, we're accustomed to putting the coefficient in the front of the exponential term, so we'll just rewrite this as 3/4, so the coefficient in front, and then e to the 3x over 4. And that will be our derivative. All right, so let's look at a couple of other examples before we go on here. So let's say that I have 1 over 7 e to the 7x. Now here, this 1 over 7 is a coefficient, so it will just tag along as it always does. So we will have y prime is equal to 1 over 7. And then our e to the 7x, we have to rewrite the exponential, so we'll have e to the 7x. And then we multiply that by the derivative of the exponent. Now, in this case, our exponent has x to the first power, so the derivative of 7x will just be 7. Now, you do, of course, need to simplify this. So the 7 and the 7 here can cross out, and you'll just be left with e to the 7x. All right, so let's look at one more example. Here we have e to a power, so we're going to use our e to the u rule that says we rewrite the exponential, so we will rewrite e to the 6x squared plus x. And then by our chain rule, we have to take the derivative of that exponent. So that derivative, bringing down the 2, will give us 12x, and then plus our x to the first derivative will just become 1, the coefficient, because we have a linear term. Now, this as it is written is incorrect, because what we're saying here with this notation is that we are just taking 12x and multiplying it by e and then adding 1. But we want all of this exponent derivative to be multiplied by e. And so for that reason, we must put parentheses around the 12x plus 1, and that is largely because of the fact that these are two terms, and we want both of these terms to get this e to a power distributed. So two terms, we must put the parentheses around them because of the distributing that we want to have to happen. And again, if it was one term like here, I put the parentheses just for emphasis, but you could technically drop them. But with two terms or more, you must put the parentheses to show that all of this is getting multiplied by your e to a power.